Hey everybody, this is Larry. This is day 4 of the February Leetcode Daily Challenge. Hit the like button, hit subscribe button, join me on Discord. Let me know what you think about today's problem. And I mean, long and behold, we're not surprised. We have the second part of yesterday's problem, Trionic Array 2. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem and so forth, right? Okay, so yeah. Today I just want to give a little bit of workout update because sometimes feel like but in case you're new to the channel, when I haven't worked out that much in the last couple of months because I've been traveling a lot and I've been just kind of going through some sickness and coldness and stuff like that. But yeah, but I try once in a while talk about my workout just because I know y'all or maybe not all of you, but some of you are struggling, doing Leetcode, and I'm just sharing some stuff that I'm struggling with, which is working out because it's just hard, right? But yeah, today I just did a 10K or so, very slow 10K, but just kind of get my legs warm. That's basically it, really. But I just feel so tired. I think, like obviously I've done marathon before, I've done ultras before, so but I just haven't done that much exercise in a while. So even the 10K is a little bit exhausting. So we'll see. Took a nap, and also I have not been sleeping that well, to be frank. But so we'll see how this problem goes. Hopefully it's not too bad. It is a hard problem. We will see. All right, let's get to it. I'm kind of need some water. But all right, fine. Let me just get some water out, and then we'll see what happens. If I need it, I need it. Okay, so you're given an integer nums of n. You have these LPQR. That's one more thing than yesterday, right? What is R? Continuous. Oh, left to right. Okay, so just a subarray, but you still have P and Q, and you divide 3 of them. Okay, so the Trionic subarray is a contiguous subarray inside. Okay, and L and R can be on the thing. That's fine. And you have one element of L to P, P to Q, and Q to R. Return the maximum sum of any Trionic subarray. Okay, so basically, we're trying to find a subarray, and then just try to find out, Sorry, hydration. But what I was looking at and maybe trying to hint at with my mouse language, my clicking language, is that n is 10 to the 5th, which means that n square solutions don't even work. So we have to think about at worst, maybe n log n, something like that. But maybe 3 times n, 3 coming from the 3 parts or something like that. I don't know. But these are kind of the ideas that I'm thinking of, right? Nothing based on the numbers, though. This part, in theory, you could renormalize, but it doesn't, because you're doing the sum. Renormalizing doesn't really make sense, or coordinate compression, maybe, depending on how you want to say it. This one is interesting that at least one exists, so we should be able to find one, right? Even if it's not if there's one, then there is one, right? When they say strictly increasing, does one element count? Because then I guess it always exists because you just have 3 or 4 elements or whatever it is, right? Yeah, there's 4 things. You have to choose 4 indexes. Oh, I guess no, because one chunk is 2 elements. So okay, all right, fine. I think one thing that I would say, of course, is that yesterday, or part 1, if you will, we definitely did not do it ourselves much favor, because we did it the n cube way, right? So there are some observations and things that, well, n cube way is just because you have to get that down at the very least from that n cube solution, because, well, if you cannot have n cube as part of your solution for the obvious reason that it just would be too slow, right? It turns out that you can actually reduce it to O of n, but with some thinking of that, well, with that one, you just have to check whether it's in a binary way, a Boolean way, whether it is or not, right? Which means that it always has to start increasing, continue decreasing at some point, which is that if it decreases at any point, then that has to be the point, right? And if it increases again, that is also the point. Sorry. I had Chipotle earlier today, like not that, like an hour ago or something for dinner, and I had too much hot sauce, and sometimes it gets stuck in my throat, and now I'm like just struggling a bit. My apologies. Okay. So I think for problems like this, and I wasn't trying to stall necessarily, but I guess it did work that way. For problems such as these, the first thing, or I mean, not the first thing, because we already talked about the first few things I look for, the constraints and thinking through it and stuff like that, what we already talked about. But after that, the thing that comes to my mind is that I'm trying to think, because we're all trying to get an n log n solution, maybe of n or something like that. The idea is, I would think about is try to figure out how to make it so that there are invariants, right? Meaning something that you can, like given this, query for this. That's kind of like the n log n solution. There's like, variation of what I just said in a more specific way, like sliding window. You have a window. You have to do some queries, right? You have a sweep line, maybe this is the last index to do something, and then now you have to do some query. So the first thing that or like the most recent thing, maybe I gotta stop saying the first thing, but the most recent thing that I'm thinking of is that, well, given this problem, what is the thing that, I would call it an invariant, but just something that like, okay, you have this, then now you can query the rest, right? And for me, the more natural thing would be the decreasing middle chunk, right? The reason for me that jumped out at me initially is because that you cannot choose it, right? Because there's just no choice, right? In a sense that I'm bringing up the drawing thing. Hang on. I don't know. I'm really bad at like making up examples, at least for the purpose of this. But the idea here is that, okay, well, you have some chunks, right? So let's say this is the middle chunk where it is decreasing, right? And you're trying to find out the increasing and increasing chunk, right? Well, first of all, is that the reason why this is the invariant, I thought I changed colors, but okay, fine. This is the invariant is that you cannot choose it, right? And what I mean by that is that you cannot choose the size. You cannot just choose a subarray of this, right? It has to be the entire chunk. Because by definition, if you try to take like a little chunk, well, it doesn't work because this is still down, right? This is still decreasing. And then now, so you have to take all of it so that, well, left of it and right of it is increasing, right? Here, though, there is a choice because here, then now you're trying to go as far as, or well, maybe not as far, but like you want to try to maximize the sum, right? Of this way, and that's kind of the idea. And there are a couple of ways you can do this. And initially, I did say like a query, and I don't. My full disclosure is that my initial thought without drawing this out, and this is why visualization is helpful because it allows you to kind of see things in a different light. And maybe for me anyway, it slows me down a little to kind of go through it. Is that I would have tried to do some kind of like weird, I don't know. I would have tried to done some like max element type thing here, right? And honestly, and that would be in log n, and that's fine. I don't think there's anything like we do like a segment tree or prefix tree, because here you have the prefix sum, and then you have here. But keeping in mind that prefix sum of this element, this element, this element, this element. It's just you go to this element plus, you know, the elements, the pairwise elements, right? So that means that if you kind of subtract this from all the elements, so this would be fine to getting the min, right? The max here. Maybe a little bit trickier for this side though, because for the right side you get to choose any index, right? Because it just go from left to right. For the right side, it is a little bit trickier to kind of do it this way with the prefix sum, because, well, you have to do like the inverse or stuff like that. And of course, I mean, yeah, let me finish my thought. Is that you have to do the inverse, you have to do like negatives, and I don't know. Maybe it's a little bit too tricky for me. But of course, the easier way is just exploring the symmetry, right? Is that you can just reverse the array and then reprocess that way. It is still a little bit annoying in that you have to map the indexes to the right place, but you are going to be able to get the min, you know, and so then now instead of prefix sum, you may consider like a suffix sum. I mean, suffix, okay, but a prefix sum on the reversal of the suffix, right? And then, you know, you can just get the min of this in log n time, and that should work, I think. Because the middle part, I don't know, there are not that many middle parts, and then for each one, and let's just say even there's n middle parts, and for each one you do a log n query on 2 indexes left and right, and that's it, and then that's n log n, right? Lazy math counting, and that's fine. The idea that I actually saw when I started writing this out, started drawing this out, is that you can use Cadane's algorithm, right? Turns out. Like if you go here, right? Well, this is literally just how Cadane's algorithm works. You just go from left to right and then right to left, and you're trying to maximize the subcomponents because, well, this component does not affect this component, and of course this just doesn't change at all, as we talked about, and that would be good. The only reason why this is a little bit scary, or could be a little bit scary without analysis, is that, well, what if this goes all the way or something? It becomes n squared. Well, the thing is that it will not, because, and this will be O of n, because you get to amortize that out. Because every element in here, it's going to either be on one scan to the right or one scan to the left, and that's it. Because everything is delimited by up, down, or increasing, decreasing, increasing, right? There isn't going to be like multiple decreasing that needs to go to the left from here, for example, because by definition, it would just go through the other one, and then you'll be like, what am I doing? You know? So I think with that amortization, that should work. And that means that we should be able to just actually implement this very cleanly, relatively, right? So our goal is to figure out the decreasing components, right? Because we don't get choice in how big it is, in the size or the sum or anything like that. And then just from those indexes, go left and right in a Cadane's algorithm kind of way, and we should be good. So yeah. So my strategy, my algorithm is just going to be fine decreasing chunks, P's and Q's, right? So P is the first element in which, so start is going to none say for I in range of n. So if num sub, and maybe, if I is greater than num sub I plus 1, then either, I don't know, right? Then here, if start is none, then start is equal to I, streak is equal to, I don't know, we have to be careful about the index, but I mean, the idea is going to be right. I say 2 because now we have to, oh no, let's just say 1 because this is the beginning and then this will count itself or something, right? Else then streak just increment by 1, right? And then else, maybe we have something like decreasing, right? And then here we have decreasing dot append. We have the start and I. I guess we didn't need streak. I thought maybe I could use streak, but it doesn't really matter. So maybe we don't need streak. I lied. And then start is equal to none, right? Yeah. And then these things I'm always really bad at. So let's just print it out real quick. So here, well, none to 4 is probably not right, right? And this is if start is not none. Very simple fix. We're very silly. Okay. 0, 1. So decreasing, that's right. And then 2, 3, this is decreasing, that's also right. Though, no, that's the negative numbers are confusing because I was like -3 to 0, is that right? But here we also forgot to do the last one, right? So if start is not none, right? So yeah, so this is why you you know, debug these things, right? Or like oh, I is not this I is gonna be n, or it's gonna be the next I, right? Well, I guess n-1 because n-1 is the last index and we're doing inclusive indexes apparently. So okay, right? And just double check it for here. It's gonna be what is it, 1 and 2, and because everything is like one element, I just want to do something real quick. Right? Just to make sure that, you know, okay, 1 and 4, that I think that's right, right? Okay, so then now that's pretty much it, honestly, right? I mean, now for each decreasing chunks, 1 contains on the left and right? And basically you just want cadenes until either you hit, you know, the boundary or something that is decreasing, right? So yeah, yeah. So then for chunk in decreasing, right, left, maybe just like left, right, in decreasing. So then now we go cadane. Maybe we start at index left. We want to go -1 for delta, and then this will give us the biggest sum. Yeah, and then maybe we have the best is equal to -infinity. We're trying to maximize, right? Yeah, maximum. And we also want to no, maybe that's fine. That's it, right? So then total is equal to sum of, and you could use prefix sum for this, but it doesn't really matter because in amortization, everything is going to just be called once, right? Because every number can only be part of one sum, so that should be fine. And then contain, right, +1. We have to be a little bit cleaner just because technically I guess this is actually not necessary to else, but I mean I want to keep it in a modular way so that we can understand that we don't create things, though it's not necessary, because if the streak of decreasing does not end by the last element, technically speaking you don't have room for the increase, right? But yeah, but we're gonna but I like to keep this like in a modular way, even though it is a for loop and it's not a function. You could still do things in a modular way to you know, make sure that whatever you call afterwards is going to be good, right? So here maybe I write if left is equal to 0 or right is equal to n-1, then we just continue. So then that means that this assumes that this has at least one element is what it gets us. And then now we do contain the start, the delta, right? And then maybe we have L best and right best, and then best is equal to max best total plus L best plus right best, right? Oops. And that should be the best idea. I don't know. It's just a regular idea. I don't know if it's the best idea. I just like to say it because I was just saying best stuff. Saying best too much. But okay. Right. So then now we go while okay, current is equal to start, total is equal to 0, best is equal to negative infinity, right? Actually, total should be okay. Yeah, I just want. I'm just thinking in my head to make sure that I get all the edge cases, and I think the thing is that we should get all the edge cases in terms of because I'm just worried about the case where like you're on the edge, but I think this should take care of all of it. Because then now we can do while current. So while current is greater than 0 and less than n, maybe, I don't know, and well, no. Well, the greater than 0 part is fine, but because current can check for current minus 1, and then here the n plus 1 is, or current plus 1 should be less than n, right? So that means that less than minus 1. Okay, and num sub, and these are all increasing. So num sub current plus is, so it has to be increasing, so it has to be less than the next number, which is current plus delta. Then we are good, and if we're good, then we go total, we add num sub current plus maybe current, we add it to delta, we add that to the sum, we check the best number for and of course we only do it after we do this loop once, so that we don't just pick one number, because one number is not going to do it. I hope I get all the cases, but that's my general thought process, right? Well, I mean, it could also be that my ideas are wrong. I mean, maybe we do need to do a segment tree or something. But all right, this is definitely not right. Wait, then how did I get -1 as an answer in general? Huh? Huh? Negative infinity. Total L best, R best. Oh, there's a comma. Wow, that's a really bad comma. Okay, I mean, yeah. I mean, that's obviously a bad comma, but at least we solved it a little bit, right? Okay, so this means that there's just no possible solution. Why is that? Let's see, right? So left, right. Okay, so best left, right is 2, 3. So 0, 1, 2, 3. Okay. So then -1, -2. And this is cadence. So I'm just, wait. No, I mean, it's not cadence. I lied. It's just like a prefix thing, right? So it's not even cadence, but I don't know. I think, because cadence you actually stop. Okay, sorry. I confused people a little bit. So let's just go, let's just call it, I don't know, F for now. Sorry, friends. But it's still, I mean, the code should be the same. I mean, it will not be because I got a wrong answer. I mean, not, I haven't solved it yet, but in theory. Okay, so 2, 3, on the total is -4. I mean, that's fine. Left best is wrong. Okay, and then right best is -1. Is that true? No, this 2, 3, 0, 1, 2, 3. Wait, is that right? Oh yeah, no, that's right. So 2, 3, -3 plus 2 is going to be -1, so that's probably right. But why is this wrong? -3. Do I get the delta wrong? No. Okay, well, I mean, clearly it says it's going to be negative infinity, but why? Why? -1 is less than negative. Oh. I'm wrong. Like I said, the negative numbers are confusing me because -1 is clearly bigger than -2, so that's why this is reading to negative infinity. What is my intentional thing? So this, okay, right? I think that's right. And we do this, right? Do we not query for this? Oh yeah, -1, -2. So then you have this thing, right? No, it doesn't. What? Is my decreasing thing wrong? Did we mess up with it? Because the answer they gave us is that it should be 1, 2, right? Oh. Decreasing. This is increasing. Did I get things confused? Yes. I am dumb. I try to be too general because when we're going backwards, of course, you're not increasing anymore. You're decreasing, right? Okay, fine. That I was trying to generalize. I mean, this is an easy fix. I mean, there are easy fixes. I'm trying to fix it in a slightly cleaner way. I mean, I don't even know if that's cleaner, right? But isn't there like a greater than, less than thing, or am I making that up? Something like that, right? Okay. I mean, I didn't think about it. Actually, it should be the other way. But wait, is it? No. Because then now you're going back. It's increasing. So greater than, if this is greater than this. Okay. Well, the reason why this is wrong, and that's fine, is because we double count the P and the Q index. The reason why I know it so quickly is because I was actually thinking about this earlier, not gonna lie, because when I was writing it out, I was like, I know that this double counts to current, so yeah. But that's an easy fix. We can change this to 0, and I think that's all. Okay. But the reason why I was able to find it so fast was I was thinking about it, and I was like, oh, I didn't really, like, I wasn't sure, and I didn't really want to look it up. I don't know, that part was just lazy. But I was like, okay, if this comes up, I'll know it, I'll recognize it, because, yeah, and I did. So, okay, so this looks okay. Let's give it a quick submit. Hopefully it's good. And yeah, that's it. How did I do it last time? Did I do it crazy segment tree last time, or did I do it this way? I did prefix sum. I mean, this is the same thing as what we did now, except for maybe, I mean, it tried to do a group by thing, right? So the middle sum is the prefix, and then, no, I did. I mean, this is a very weird looking code, but it's basically does the same thing of what I did, but I think I did it much cleaner today, for sure. But I was wondering if I was, because I really was wondering where I did like a log n thing, but it turns out I did the same thing, but today I feel like my code is cleaner, right? I mean, you don't even need this, right? As we said, but it shouldn't change that much. But I just wanted to show you all the code. But yeah, let's go over the code real quick again. Here we divide things into a decreasing. We only care about decreasing chunks because of the invariant that we were talking about. I call this cadence. I think I was just confused for sure, but the idea is still true. Is that you're just trying to do like a prefix max from the thing. And the key thing to note is, I mean, the algorithm, the code-wise, is 100% based on algorithm, right? Because if you do, I mean, I guess you could always YOLO, but if you didn't prove that this is going to be linear, then you might not do it because you'll be like, oh, this is n squared, right? So, I don't know. But yeah, but overall, it is going to be linear time, linear space. Yeah, because of decreasing, I suppose. But yeah, that's it. That's all I have with this one. Let me know what you think. Thanks for watching. And yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.